So for the start of Unit 6, our first topic is vertical line tests, horizontal line tests, and invertible functions. So first of all, what is a function? A function is a set of all ordered pairs x and y, where for every value of x, there is one and only one value of y. Now that sounds like a lot of math speak, so let's put it in different terms. X's are boys and y's are girls. For every x, for every boy, any boy can only have one girlfriend. That's it. Can't cheat, no cheating. So one boy can only have one girlfriend. However, a girl, a y, can have as many boyfriends as she wants. So a y can have as many x's as it wants, but an x can only have one y. Okay? So one way to test for this is called the vertical line test. And what you do is you draw a vertical line through a graph at any point on the graph. And it can only hit one spot at a time. Okay? It can't hit two spots. One line can't hit two spots. If it only hits one spot, it is a function. If it hits more than one spot, it is not a function. So let's look at some examples. Let's make this a little bit red. Okay, so if I draw a vertical line at any point in time on this graph, one vertical line will only hit the graph once. It hits it down here, or down here. But it only hits at one point in time. So this is a function. Now, if we look at the next graph, if you draw a vertical line, this one line hits in two spots, here and here. Because it hits in two spots, this is not a function. Okay? So what we're looking for is functions that are invertible. An inverse means that what we're doing for an equation is we have an equation, let's say y equals 2x, and we flip the x and the y around. So now it says x equals 2y, and then we solve for y. Okay, so that's what an inverse is. You're flipping the x and y values and then solving for the y again. So if it's able to be flipped, it's invertible. Okay, and the way to check that is a horizontal line test. So if you check a horizontal line across a function and it does only hit one spot, just like the vertical line test, then it is invertible. Okay, if it hits more than one spot, then it is not invertible. Okay, so let's look at some of these problems. So we have a function f of x equals x. All right, if we did the vertical line test, it passes, so that's good. Okay, but what we're going to do is check the horizontal line test. So horizontal line goes across. At any point in time, it only hits one spot on the graph. So this is invertible. Let's check x squared. Okay, so it passes the vertical line test, so that's good. So let's check the horizontal line test, and well, that's not so good because it hits two spots in one point, or on one line. So this is not invertible. Okay, let's check x to the third. It is a function if it passes the vertical line test, and it is invertible because it passes the horizontal line test. Only one spot, so this is invertible. Okay, if you look at x to the fourth, it'll pass the vertical line test. Oops, that's too many dots. There we go. It does not pass, though, the horizontal line test, so this is not invertible. Okay, so now what we want to look at is some similarities. Is there anything we can see with our power functions if the degree is odd? So this x to the first up here, x to the third are the odd functions. Is there some kind of correlation you can come up with for odd degree power functions? Well, you should see that odd degree power functions are invertible. Okay, what about evens? Evens, we have x squared and x to the fourth. Well, those are going to be not invertible. And that is it. Try the practice and good luck.